Alright, we're in Chapter 3, Section 3 on conditional probabilities, so we'll be doing some conditional things here. Alright, number 7. Compute the following probabilities in connection with the roll of a single fair die. So, let's start off with here our sample space for the single fair die is going to be 1, 2, 3, 5, 6. We have the 6-sided die. Okay, so the probability we'll call E for even. So the event even is 2, 4, 6. So that's going to be the probability of any of those. So the probability of E is going to be given a probability of, so we have 1/6 for the 2, plus 1/6 for the 4, plus 1/6 for the 6. Since there is a fair die, that it's 1/6 probability for each outcome. So this is 3/6 or 0.5. Okay, in B, we have the probability that the roll is even, given that it is not a 2. Right, so we have another event here. We have the probability of the event. We have the event E. This other event, let's call it N2 for not a 2. And not a 2 means it's going to be a 1, 3, 4, 5, or a 6. And the probability of it not a 2 then is going to be 5, 6. Because probability 1/6, 1/6, 1/6, 1/6, 1/6. Right, so now we have the conditional formula here. What we're wanting to know is what's the probability that it's even given it's not a 2. So here we have to go back to the formula from the chapter. We've got the probability of the section. So the probability that E intersect N divided by the probability of N, so not 2. Okay, so we'll have to find what's the probability of the intersection. So the probability of E intersect N2. So let's see, E intersecting N2. That's going to be the intersection. So this will essentially be the probability of getting a 4 or a 6, right? So we have, those are the intersection of the 2. Those are the only things that are in common with the 2. So that's going to be 2/6. Alright, so the probability this is going to be 2/6, so the intersection divided by the probability of N2, which we just looked at, is 5/6. So this is going to be 2/5 equals 0.4. Okay, for C, here we're wanting the probability of the roll is even, given that it is not a 1. So let's say not 1. So in this case, not 1. It's going to be 2, 3, 4, 5, or a 6. So again, the probability of not 1 is going to equal 5/6. Yep. Wait a minute. Okay, yep, we're good there. So I want to know the probability that we have an even, given that it's not a 1. We're just going to the probability that it's even intersected with not 1, divided by the probability of not 1. Okay, in this case, we have, we'll have to come back here again like I did above, the probability that E intersect N1, so they're probably even and not a 1. So the probability that it's even, let's look at the intersection of even and not a 1. So even and not a 1 is going to be that 2, 4, 6. So that's going to be 3 of elements. That's going to equal, what's going on? Oh, I did it again. There we go. Stop. Okay, let's come back and get rid of that draw I just did. All the extra stuff. Okay, there's a button on the side of the pen here I'm hitting. Okay, so we had 3 elements, 2, 4, and 6, so that's 3, 6. So here we're going to have the probability is going to be 3, 6 divided by the probability of n1, which is 5, 6, which is going to give us 3/5, which is going to be 0.6. There we go. So that's what we've got on this one for example problem 7.